All right, are we live?
We are live.
Hello, everyone. Welcome to the Audio Programmer Meetup, and thank you so much for tuning in. It's actually now our 6th Audio Developer Meetup. That's obviously the August edition because we're in August. My name is Timur. I'm really excited to be here. Tonight is a very, very special night for many reasons. First of all, tonight is our very first themed evening. So tonight we have a theme for all the sessions, which is modern programming languages in audio. So we're going to hear a lot about that. And also, there's been quite a few changes. So both me and Josh, as you can see, if you're tuning in regularly, are at different locations. So I'm actually now currently in Greece on an island. So the beach is just somewhere over there. I just arrived here this morning, so it's all a bit improvised. The Wi-Fi seems to be good enough. Josh also just moved house. So, and the other thing, as I'm sure many of you are aware, is that the different locations where we are, including our guests tonight, it's very, very hot. So we have basically fans running and brains melting. And so let's see what happens. One or two things might go wrong tonight. So if that is going to happen, then please accept my apologies. So we're just going to go with it and see what happens. Speaking of Josh, hi, Josh. How are you doing tonight?
I'm great, and I'm really happy and excited to have so many esteemed guests with us, and we're going to have an opportunity for everybody to introduce themselves in just a moment after a couple announcements. So first announcement is, as always, thank you very much to all of our sponsors that are supporting the Audio Programmer Meetup. So we have JUCE, Sonics, and Focusrite. So thank you very much for your continued support. And we have a very big announcement that we'd like to make. The Audio Developer Conference is back, and it's going to be happening November 18th and 19th. This year, the conference is going to be a virtual conference, and there is a call for proposals. And Timur, can you just talk a little bit about how people can submit papers for ADC this year?
Of course. So this year, we haven't. This year, you can submit your talk by going to submit.audio.dev. And you have until 14th of September to do so. So you have just about 5 weeks to submit your talk. So please go on the website, submit.audio.dev, submit your talk to ADC. And the format is going to be a bit different this year. So all the talks are going to be 50 minutes, including questions. And since it's an online conference, so there's going to be exciting stuff happening about how to make a conference experience online. But as a speaker, you can also choose whether you want to, just like you can do at the meetup here, stream your talk live, or whether you can pre-record your talk or and do just a Q&A live. So you have that option as well. And it also doesn't matter whether it would be your first talk at a conference or whether you're already a very experienced person in the industry. So ADC is there for everyone. So please go to submit.audio.dev, submit your talk, and looking forward to that conference.
Yeah, me too. And I think it's going to be a great one. And I think that now would be a great time for all of our guests. As you can see, we have quite a few guests today. And we can go ahead and I'll just say your name. And if you could just say a line or two about yourself. So we will start off with Ania. Ania, hi. Thank you for joining us today.
Thanks for having me. Hi there. So my name is Ania Wszeborowska. I'm a software engineer at Ableton, working on Max for Life. Well, I've been active in the Python community for the last 10 years and have a status of managing member in Python Software Foundation. Recently, I've been speaking and giving workshops on using Python for audio processing. And at Ableton, even though I'm technically a C++ developer now, Python remains my language of choice for rapid prototyping and automating repetitive tasks.
Amazing. I'll try to go in alphabetical order. Francesco, hi.
Hi, thanks for having me. So I'm a student at the University of Huddersfield. I'm completing my master's there, and I'm very much interested in new programming languages, especially regarding audio, both for like DSP and for general structuring of audio events. And that's what I'll be talking about today, mainly the DSP part. The other part is another project of mine, but that's for later, I guess.
Fantastic. Hi, Ian. I can't. Oh, I can hear you.
Hi, yeah, so I'm Ian, and I'm a software developer based in Berlin, and I've been here since 2011, working for Ableton until last year, and since then working independently and consulting for different companies, including Lofelt, who we're going to hear more about later, I think.
Great. And Jules.
Hello, everybody. Yeah, I'm Jules. I'm best known for being responsible for JUCE and also Traction and Waveform. And tonight I've been dragged along to represent my new language, which is Soul, which is what I'll be talking about later. Yeah.
Great. And Neil Burdock.
Hello, everyone. I'm Neil. I'm the current VP of Engineering at Lofelt, so that Ian just mentioned, a haptic startup based in Berlin. I'm currently responsible for like engineering practice, high-level tech strategy. I think that out of the rest of the group here, I'm probably the least hands-on engineer of the group, but don't hate me. I was at Ableton before. I know Anna from there. I know Ian from there. I think that's it.
Great. And Ruth, hi.
Hello. Hi, everybody. I hope it's not as hot where you are as where I am right now because I'm melting. I'm Ruth. It's lovely to be here. Thank you for inviting me. I've been a web developer now for, gosh, almost 20 years. I primarily do web development in education now. I'm a self-employed creative engineer who mostly works on amazing interactive art projects, those which do feature audio.
Fantastic. And are we introducing? So we're going to start off with Francesco Cameli. So Francesco, if you could just introduce yourself and let's go ahead and start the talks.
All right. So should I just share my screen?
Yes.
Sweet. It says that host disabled participant screen sharing.
Okay. Here we go. There we go. Try now.
Yeah. Can you see my screen?
Yes.
Fantastic. So, hello everyone. I'm Francesco Cameli, and I'm going to be talking about Omni, which is a domain-specific language that I've been developing for the past 9 months, and it's going to be part of my submission for my master's thesis at the University of Huddersfield. About me, well, I'm mainly a composer and improviser. I'm not an engineer at first, at least. I'm self-taught, so I've got no formal computer science background. So everything I've done is basically like out of my own interest and out of my own needs as a composer and improviser. What is Omni though? So it's a domain-specific language for developing audio algorithms, and its scope is to be as minimal to use as possible while being cross-platform and cross-application, which means that you would write your Omni code once, and then you would expect that to be deployed, everywhere. In this case, everywhere that you've written a wrapper for, but more on wrappers later. There are similar projects out there. The most notable ones I would say would be Gen in Max, which is a proprietary language inside of Max MSP, which allows you to still do low-level DSP. It's very easy to prototype code with it, and it exports to C code. But my main problem with it is that it has fixed data structures. By that, I mean that the individual objects that you have are given to you, and that's the lower level you can get into. Another language out there would be Faust, which is developed by Graham in Lyon. It's a functional programming language, which is, as Omni, it's open source and it's cross-platform. But my main problems with it would be, well, the functional approach, which I don't personally enjoy that much, and also the monolithic approach that he has to exporting stuff. So the Faust executable can export code to a plethora of things, but those things are all embedded in the same executable, while my approach will be more of having a more minimal executable, and then you would write wrappers around that to export to different things, and more on that later again. So why did I develop Omni? Well, as I said, I wasn't satisfied enough with the current tools out there, and also, but at the same time, I'm not skilled enough to write up my language from the ground up in terms of like, you know, writing my own parser, lexer, compiler, etc., etc. Maybe do some LLVM stuff. I mean, I looked into it, but I realized quite soon that it would take me much more time. So what's the solution for me? Well, the solution for me is a thing called meta programming, which is basically something that allows you to write code that produces other code. And that's the code that's going to be compiled. And in my case, the language I'm using to develop this Omni language is NIM, which has amazing meta programming capabilities. So the whole Omni language is actually developed in NIM macros in this case, which are the core of NIM's meta programming. What does Omni look like though? Well, something like this. It's basically based around a scoped syntax where each individual, scope, which is determined by a keyword and then a colon, has a different purpose. So it's kind of, let's say, I wanted to get it to do the most minimal thing. So just the DSP part without having any overhead. So this is a language that's just for the DSP or the low level algorithms. So it allows you to have custom data structures, and as I'm going to show, and it's guaranteed to be memory safe because all memory allocation all happens in something called the init block, which I'm going to be explaining later again. So the first two blocks will be the ins and outs block, which allow you to define your number of inputs and outputs, names for those, and for example, default, minimum, and maximum values for those. The next block will be the init block, which is where all the memory allocation will happen if you're declaring your own data structures that you want to use. In this case, in this example, we're simply going to declare a variable called delay, and it will be of type delay, which is an inbuilt struct, and that's going to be allocating memory of delay length in terms of length of samples for a delay line, for example. Then inside of the init block, there's another thing called the build block, which allows you to pass on specific variables that you allocate in the init block through to the perform and sample blocks, which are the ones that actually do the DSP processing. So the perform block happens at the block level, while the sample block happens sample by sample. So after going very fast about that, we're going to do a live demo about it. So how would you install Omni? So if you have NIM installed, I'm using the Nimble package manager. So you just go Nimble install Omni. And that's it. You would have Omni installed. Now you would have the Omni compiler executable. And let's do some Omni code perhaps. So I've got some examples here. So if anyone wants to interrupt me at any point for any questions, just feel free to do it. So this is a very simple example of a sine wave, for example. So as you can see, well, I've also developed this VS Code syntax highlighting just to make things a little bit clearer. I'm using VS Code as my text editor. So here, for example, we're just declaring one input, which with the name frec, and our default will be 440. And let's say that our oscillator would go from 1 hertz to 20,000. And this is where we would express that. Then we just want to have one output, which is the actual oscillator. So in the init block, we're declaring a variable called phase, which means that this variable will be kept alive. So we can, for example, increment the values on that, store stuff on it. And that's what we're doing for an oscillator here. We're actually calculating, for example, the frequency increment with the first input divided by the sample rate of the system. Then we're just saying, okay, we want the sine of that times 2 pi at the output. And then we're just updating the counter. So if we want to compile that, we would just call Omni and then Omni sine.omni. Sorry. And what we get back is actually a share library and the header file. So the header file contains all the entry points for that share library. The most notable ones will be the init global or init alloc, which allows you to, if you're writing a wrapper around Omni, around this shared library that you generated, to define your own, for example, allocators or your own print function so that it can be embedded anywhere. The other, of course, important parts are the initialization, which take care of initializing the bit of memory, and the perform, which is actually doing the DSP loop. So to hear what we created, what we coded, I'm going to use the Omni Collider wrapper, which is a wrapper around Omni that generates super collider unit generators, because that's what I mainly use. And I would just call Omni Collider. So this is a separate executable though, because my idea for Omni is that the Omni compiler will be very minimal. We'll just compile shared or static libraries, and then you would write wrapper around this procedure to create your own wrappers for whatever projects you have. So it means that I don't have to maintain, for example, if you want to develop an Omni wrapper for open frameworks, for example, which I don't use, I wouldn't have to maintain it, or pure data or whatever, or a BST wrapper. That this allows me both to code it myself if I need it, but also having someone else doing the job instead of having a plethora of like pull requests and having to maintain a huge code base, which I wouldn't use personally, because the first thing for me for Omni is that I wanted to use it to create my own algorithms. So enough about that. So we created this Omni sign unit generators. So if you go to Super Collider, for example, we have the Omni sign here. And as we can see, we have the default value of 440. If we want to play that out to our speakers. So I just want to, I'm going to start super low with volume because I don't know. Can you hear it?
Yep.
Yeah, okay. So yeah, as we can see, we created a simple sine wave oscillator, which is not that exciting to be honest, but it's just to show the like sort of the hello world of the audio realm in a way. So onto a little bit more complex example, we're introducing structs now. So a struct is a way for a code, for a programmer to define its own data structures. For example, we're defining a struct called phaser here, and a def, which is a function in Omni, which is actually gonna use another inbuilt struct, which is called data. So data allows you to have an array of anything inside of Omni. So in this case, we're declaring an array of phasers, type phaser of the number that we input, for example, in the init block in this case. And then we're initializing those phasers, and we're just returning the array. So in the init block, we're just getting the number of sine waves that we want to generate from the user. We're calculating, for example, a scaling of the amplitude. So this is calculated the first time you create the object, not every sample. And then we're creating those phaser by simply calling the def. In the sample block, we're just looping through the array of phasers, updating the phase coefficients according to like a multiplication of the frequency. So we're generating like sort of a bank of sine waves with equal amplitudes. So if we compile this, sines.omni, well, we go into Super Collider, Omni sines. So for example, we can have, if we have just one sine wave as before, we're just gonna have the same, you know, let me just turn the volume down again. The same sine wave as before. But in this case, for example, by simply adding to the code this data structure, which allows you to have an array of anything, in this case, an array of a struct phaser, this allows us to have a bank of sine waves just like this. So if we want 10, if we want 100, well, it's going to clip because it's all calculated like we're calculating sine. We're not taking like a sine table to save memory cycles, but just to show you that, okay, we have 10 sines, and it's as easy as that to just code it. Again, this is all coded in the same Omni file, for example. What if we want to split up our code into more reusable bits of code? Well, in this case, we're introducing something called require, which is sort of like an import statement in Python. So we split our file into omniscience2.omni and phasers.omni. So phasers.omni has two structs in this case. So the struct phaser that we had before, and then a struct phasers, which is storing the number of phasers, the amplitude, and the data of phasers, so the array of phasers. And we have the same function here in initializing it. So we're simply requiring this bit of code here, and we're just using it to initialize, and then we're going to use this. So we pretty much abstracted out the core of our algorithm to another file that we're going to reuse, perhaps not just in this project, but in whatever project. It's just an easy way of you to structure your DSP code. And the results will be the same. Again, we can even abstract even more. For example, in Omni Science 3.omni, we actually have just 13 lines of code. We are just declaring number of inputs and outputs and simply calling an initialization function and a process function. And these ones are the science.omni file, which is requiring the phasors that we had before, and we're just adding a process that's just abstracting out the calculation of the sine waves in this case. And for example, if we compile this, and we go to Super Collider, we're going to have the same result, but we have more bits of reusable code that are easier to maintain. A little bit more of an interesting example would be to using the same bit of code, but having the amplitude scaled, for example, by the inverse. So we generate sort of a bank of sine waves that will generate a sawtooth in a way. We're just generating the harmonics with a decreasing amplitude. So if you see here, the code is actually the same, the code we're actually compiling, because we're still calling the init phasors and still calling a process function. But this time we're importing it from another file, which is called science2saw, which is pretty much the same as the one we had before here. It's just that the amplitudes are scaled by the invert, like they're just scaled by the count of the number of sine waves, so that we have the harmonics being generated. So we compile this. Omni science2saw, and we go to Super Collider again. This time we're going to have an approximation of a sawtooth wave according to number of harmonics we gave to it. Of course, the more harmonics we give it, the more precise we're going to have it. Of course, this is not the way you would generate a sawtooth wave, but it's just to show how flexible is the Omni language in terms of like declaring bits of reusable code, of DSP code, that would look as simple as possible, as minimal as possible, and I think are quite elegant in a way. But that, I mean, of course I'm biased because it's my project, I guess. So future work regarding the language. So there's a lot of work, of course. It's still a very young project. The main thing for me would be to develop some sort of hot code reloading or JIT compiler for the Omni language, so that sort of like Gen, you would just have this sort of this object, or whatever you want to call it, that can recompile Omni code as you code it. Another interesting thing would be WASM compilation, so using Omni code on the web. Of course, Omni test to test algorithms on the fly, it's directly linked to having hot code reloading or a JIT compiler working. Then oversampling embedded directly in the language, FFTs support, and other things like this. But of course, these are still future work that's going to happen at some point, but it's not there yet, of course. So I hope I gave a rough introduction to the language. Of course, there's a lot to talk about. If you're interested in this, you can take a look at the website, which is right here, at this link right here, which is a very simple website that just shows a little bit of documentation about all the different parts that I don't have the time to look into, but for example, stuff about the syntax, why things are like this, how you like the best practice to declare variables, a reasoning why I don't use let or var statements and stuff like that, and all sorts of other things that there's no time to look into. The repository, on the other hand, is on GitHub at this link, so feel free to check it out and fork it, use it, download it, and I guess that would be it for me. Other questions?
Great. Thank you very much, Francesco, for your presentation. While we're waiting for other questions to come in, I had a question. Do you have any way of handling time domain types of situations, so things like delays
Yeah.
sequencing.
There is an inbuilt delay. Let me go to the website. There's an inbuilt delay class in the standard library. You would just declare it as a, you just declare it in your init block, and that would just take care of initializing it. And then you can call some sort of functions that are developed for you, like a read function and a write function. It's taking care of like cubic interpolation, all the sort of things that you want to do with a delay line. You just have to tell in the sample block, sample by sample, like what you have to write in the delay line, what you have to read out, and that's it.
Great. And how long have you been working on this for?
Like 8-9 months, something like that.
Wow, amazing. And where did the original inspiration for this come from? Did you feel that?
Yeah. No, it's interesting because at first last year, I graduated with a project called Julia Collider, which embedded. I don't know if you know about the Julia programming language. You basically embedded the Julia runtime inside of Super Collider, so that you would call the JIT compiler of Julia while using Super Collider memory. It was kind of this kind of bloated project, but it will allow you to write your Julia scripts and use them as Super Collider unit generators.
Mm-hmm.
So that's where my interest first come of developing my own language, or sort of my own syntax. I wouldn't call this a proper language. It's a more of a DSL, very specific, because I'm scared to call it a language because it's all developed via meta programming. So it's not a proper language per se. It's more like a dialect in a way of the NIM programming language.
I see.
But I guess the NIM programming language itself is also kind of a new trend, right? So I just I know an embedded audio developer who is also very excited about NIM, and maybe I can convince him to do a talk about NIM at some point at this meetup. I very much hope so.
I mean, yeah, NIM is a very fascinating language to me. Of course, I don't come from any bias background, since I'm self-taught. I haven't worked. I worked 6 months at IRCAM and 6 months at GRM in Paris as my placement year 3 years ago. But I'm not like an experienced developer biased by other languages, let's say. So I just found out about this language. It was quick enough. It was fast enough, and it would leverage on other strength. Like, for example, it compiles down to C code, and then you can use whatever C compiler to that. So that's, to me, that's a big plus, because I don't have to maintain, for example, a Bella board support, because that comes already, because the Bella board has a GCC compiler. So I don't have to maintain that. But so this compiles everywhere that C compiles to, in a way.
So do I understand it correctly that you basically it's basically a meta language on top of NIM, and then NIM itself is a new programming language which compiles down to C?
Yeah, exactly. Well,
so
NIM
kind of
compile down to C or JavaScript, so it's actually easy to do web stuff as well. But if you, of course, you want speed. NIM itself is a garbage collector language, but in my case, I'm using it without any garbage collector. Like, you have the option of turning the garbage collector off, and I'm handling my own memory in this case, of course, because it's quite sensible for real-time audio to know when you're allocating memory, when you're freeing memory, and make sure that doesn't ever happen in your DSP loop, etc., etc. But NIM allows you to do all this sort of things. So Omni sort of generates NIM code under the hood, and that NIM code generates C code under the hood, and that C code is compiled with a C compiler. That's the road that the Omni code takes down to being compiled.
That's quite an interesting stack that you have going on there. It's
I have I'm not sure if that's my dog barking or somebody else's.
I think it's here. Yeah, apologies. So I'm here in Greece, and I just arrived here today. So I don't really I'm kind of outdoors, and there's like neighbors and dogs and cats, and there was like people drilling something behind me earlier. So it's a bit unpredictable what's going on. I'm gonna try to mute my mic when I'm not speaking. Maybe that's gonna help.
Okay.
So it's a bit today it's a bit unpredictable meetup.
That's okay. Okay, we have a few questions from people. So Sid asks, what is NIM?
That's a good question. It's a programming language. It's a new programming language. Well, not so new. I think it's like 9 years old now or something like that. But it's getting attention, I guess, just lately. So it's a programming language. It's a systems programming language. So you would just use it as a drop-in replacement for something like C, C++, or Rust, which has amazing meta programming capabilities. So meta programming allows you to write code that generates other code.
Okay.
In a way, that's the most simple definition I can come up with in a second.
Okay. We have another question from Sean Laptiste, who asks, what is the most complicated processor that you have created with Omni?
That's interesting. Well, I've coded the forces. I don't know if anyone knows that. It's a Eurorack module.
Nice.
Which I think there is somewhere an example in Gen. So I just copied that stuff out and coded in Omni. That was quite a complex one. I've developed some reverbs, artificial reverbs, some feedback delay networks, some filters, but those are kind of simple, like in a way, like yeah.
Very cool.
Oscillate, like anti-alias oscillators. I don't know.
Okay, great. And there's a question from Staging, I think. I hope I pronounced that correctly. So, and he says, so this transpiles to C or C++, or does it also compile that code, i.e. using LLVM to binary directly?
No, it just so I don't handle myself the G transpilation, the C transpilation. That's something that NIM does.
Mm-hmm.
So I generate, Omni generates NIM code, then NIM code generates C code, and the C code gets compiled with whatever compiler you want to use for compiling that C code. So it's not like if you want to use the C-Lang compiler, it's not using the LLVM intermediate representation at any stage. It will be interesting to look into that. There's actually some NIM bindings for that, but I haven't had the time to look into those.
Okay. And I imagine the answer to this would be no, but can you have external MIDI, an external MIDI device's input?
No. So Omni just takes care of the DSP. So I wanted to have something extremely minimal that just does that one thing, and then you would, use that. It just takes care of doing the DSP. Then how you would interface with that it's another topic, I guess.
Great. Okay, that appears to be all of the questions. Thank you very much, Francesco.
No,
pardon me.
Thank you very much to you.
Yes.
It's been fun.
Thank you. So now's a good time for us to move on to our next speaker.
Right.
Take it away, Timur.
Yeah, so our next speaker is Ian Hobson. Hello, Ian, are you here?
Hello. Can you hear
yeah.
me?
So so thanks, Francesco, for this talk. So we talked already about, I guess, several programming languages already. But this is a programming language special, so we're going to talk about more programming languages. And the next one is going to be Rust. So Ian, obviously, so first of all, you're a former DSP principal at Ableton. Now you're an independent developer, but also I remember that you've given several talks at ADC. So you're kind of a regular speaker there. And the last talk I remember from you, which I think was in 2018, was about Rust and how to use that for audio. And I think at the time I was really excited about that because no one was really using Rust for audio as far as I was aware at the time, or at least not in a way that the community would be aware of. And you kind of gave a talk about how to do that. And I found that very interesting. Obviously, that was several years ago. So things have changed since then. So you're still doing Rust. And I'm really looking forward to hearing where we are with Rust in audio tonight from you. So welcome, Ian.
Great. Yeah. Thank you. And thank you for inviting me to do this. I appreciate it. It's a fun thing to do. I'm happy to be here. So I share my screen, right?
Yeah.
Let's see. Do I do this? Yeah. Yeah. So as Timo mentioned, I gave this talk at ADC a couple of years ago. And that's really my whole connection with Rust. I'm not like a big contributor in the community, or I haven't like released some like large projects in Rust, but my background really was one of curiosity over several years following the Rust project and seeing it develop and to become what I thought could well be a viable alternative to C++ for real-time audio development. Because for a long time, it really felt like C++ was the only choice that we had. Yeah, so anyway, I mean, I was introduced earlier, so I can skip over this. And also, yeah, the talk was called An Introduction to Rust for Audio Developers. And you can go and look it up on YouTube if you haven't seen it and you're interested in Rust in the context of audio. I'm going to skip over a lot of the introductory material. I'd say, like normally in a Rust talk, maybe I would go through a few of the basics, but we only have 30 minutes. So I want to kind of try and dig a bit deeper into the language. And also, yeah, like Timo mentioned, maybe give an update about what's changed since I gave this talk in 2018. So one thing that's changed is that we've seen a lot more industry adoption. So large companies are paying attention to Rust now in increasing numbers, and like it's quite amazing to see how quickly this is happening, actually. And one of the key things that's come out of this, there are several reports where large companies have looked at all of the security issues that have been found in their software projects, and a consistent number that pops up in these reports is that 70% of their bugs, security bugs, are related to memory safety. And the memory safety being the kinds of errors in handling memory that crop up quite often when you're writing C or C++ code, where maybe you're accessing memory outside of the range which you think that you should be in, or maybe you're accessing an object which has been deleted, or well, there are all kinds of ways you can make mistakes. And yeah, it's a pretty consistent finding that has popped up so far. And something that is really important to take away from looking at Rust is that there are whole classes of bugs which are impossible to write if you're working in safe Rust. And that's really the key differentiator from Rust to other systems languages that came before. And you might be thinking, well, who cares about security, because we're dealing with audio development, and maybe this doesn't matter so much to us. But ethics aside of being sloppy about security, actually the kinds of bugs that we're talking about come up again and again when you're working on audio algorithms, or at least they have in my experience, where I'm running into these types of errors. Maybe you spend a few hours debugging something really hairy and it turns out that an object wasn't initialized correctly, or that maybe there's some undefined behavior and then the debugging experience is inconsistent. And those kinds of bugs are not so much fun to deal with and to debug. Now, another thing that has developed since 2018 is that Rust has continued its run as the voted most loved language in the Stack Overflow developer survey. So that's 5 years in a row that people have taken this survey and voted Rust as like most loved. And it's a bit of a strange thing to point to, I think, but it's interesting to me because it speaks to this idea that you can actually love a language. I find that quite interesting. Or that if maybe we scale back the term, like maybe love is a bit strong, but like this kind of emotional connection that you get to the tools that you use, I find very interesting. And what does it really mean for people to be like claiming that they feel this way or declaring that they feel this way? And so then I started thinking, well, what is it that I see in this language that I feel that strongly about? And I'm not sure if I would say I love Rust at this point, but maybe we're not at that stage of the relationship yet, but I really enjoy using the language. And at this point, I'm using it full time. So since leaving my work at Ableton last year, I've been able to use Rust as my primary language in all of my work. And so it's been a good run of like 10 months now or so where I'm using Rust full time. And also I've actually managed to get some audio analysis code, like real-time code shipping with Lofelt as part of the iOS SDK, which I guess you'll hear more about later from Neil. So to highlight some of the aspects of Rust that I like, I wanted to connect some of the ideas to a project that I've been working on. It's an old project that I dusted off. It's a granular synthesis engine, and let's see if I can get it running. And maybe turn up the, right, maybe you can hear this. So granular synthesis, of course, is where you take lots of slices of sound, very short slices from like a larger sound, and then you window them and you string them together to create like time stretching effects or drone-like effects. You can do lots of fun things with it. And it's a really good engineering exercise. So if you haven't implemented a granular synthesis engine before, I would highly recommend it because it's a good fun thing to implement. Anyway, you can mess around with it and find sounds and play around. So, good times with granular synthesis. Oh yeah, and here's an illustration of what's going on. You have a larger sound buffer, and then you take short slices, smooth them out, and string them together. So you have lots of overlapping grains to produce these larger effects. And yeah, I borrowed this from the internet. You can find it here. So that gives us some context for some things that I really like about Rust, or even love. And the first one I want to talk about is the ergonomics of the language. In particular, Rust enums and pattern matching as a core language feature, I think are a really useful, pleasant thing to use like in your day-to-day code. And one that you'll encounter a lot in Rust is the result enum. And what you'll see here is that there are two variants in the enum, and these enums both have a value attached to them. So this is a lot like the std variant in C++. It's essentially the same concept, but as a core language feature. So when you call a function, which may succeed or not, it will return a value, and that value could either be an OK value of type T, or it can be an error of type E. And so then when you're using functions in Rust or a library, often it will be written with this result type as the primary mechanism for reporting success or failure. And in the granular synthesis engine, we need to load lots of sounds from disk. And a load sample function is the main entry point for this happening. It returns a result, and the result is either a vector or a dynamic array of stereo frames. So we're going to create a stereo sample of a particular format. And in the error case, we're returning a string, which will have some information about what went wrong. And inside the function, we're calling an open function on wavReader, and we'll come to that later. Passing the path, and if it was successful in opening the path, then we get a reader as the OK return value. And unpacking the reader is achieved by using the match keyword. And so match on some enum type, or well, match on any value that can be matched against. And it's not just enums, but for now, we'll just deal with enums. You get the OK value or the error value, and then you're able to work with the contents of that particular value type. Now, this is, of course, like possible in C++ and other languages. I'm not like making a claim that Rust is particularly unique here. It's just that I find the fact that it's baked into the language so deeply and from the very early stages of the language that it has a very nice, clean syntax to it, and it becomes very natural to use this style of coding like regularly all the time. You end up using it a lot, and that means that it's like second nature to use this as a tool. So then another example of matching here is that to load the sample, we want to convert the source material to a particular format. And what we need to do is look at the number of channels in the sound, the bit depth of the sound and the sample rate, and then, well, not sample rate, sample format, sorry, whether it's an int or a float, and then call the correct conversion function based on the contents of the sound. And being able to just say match on those three values, and then like here are the cases that we can handle, and then there's a fallback for the cases that we can't handle, is very pleasant to use. And I really enjoy like this style of programming. Things that I love about Rust number 2. So cargo is the standard entry point for your project. It's the main tool that you're using when you're dealing with Rust. It's the build system, it's the dependency manager, it's the command you use when you want to run tests or open your documentation. It's a really powerful tool. And the fact that it's the standard tool that's used by default when you're dealing with a Rust project means that you get very familiar with it, and everyone else in the community and ecosystem is very familiar with it. So it's really nice that this is the default thing that is available from the start. So if you're looking for a library to integrate into your project, so for example, we need a WAV decoder. There are a collection of libraries out there that do WAV decoding. You can quickly find one of those libraries just by a simple search on the command line, or you can go to the website and then you can see all the links to the GitHub repos, etc. And you can audit, like find a project that you think would work for you. And then adding it to your project is trivially easy. So you just list it as a dependency in your cargo.toml file, which is your project settings. And that one-liner will cause Cargo to download that version of the software, compile it, make it available in your project. And then in our load sample function, WAV reader is coming from a use statement. We're saying use hound WAV reader. And that's literally all you have to do to integrate like this really nice library into your project. Things that I love about Rust number 3. So traits are this like core concept in Rust of how you define interfaces for different types. And they're used for both compile time generic interfaces like C++20's concepts. And they're also used for runtime interfaces, like virtual base classes in C++. So it's the same concept for both types of behavior, which is quite neat. And an example of how they look. So in the engine, in the granular engine, there's a lot of linear interpolation going on. So we have a lerp function, and here it's implemented just for floats. So F32 is the 32-bit float type. And we have A and B as values, and we want to interpolate between them with an X factor. And that equation works out to give you linear interpolation between A and B. And that's nice, but it only works for floats. If you want to make it generic in Rust, it's very similar to C++. In that you use angled syntax, and then you have types that are available through your function. And we're going to take A and B as types T, and then have a separate type. Well, that's a type, that should be X. A separate type for the interpolation factor. And that allows you to have your custom types, but then have a scalar value for interpolation, which is quite useful. And then in a generic context, where you're making use of the types, so in this case, we're performing arithmetic operations on the types, you need to spell out in the function, in the context of where the types are defined, what traits you expect those types to implement. Now, it could be that T implements many other traits. It doesn't have to only implement these traits, but it at least will have implementations for these traits. And you say that T can be added to itself. So the add trait, like for T, the sub trait for T, that's subtraction. Mul, here we're saying that we need to be able to multiply a T by an X and then receive a T as an output. And that's what you see here. B minus A in the interpolation gives you the range size, and then you multiply it by the interpolation factor. And that B minus A would give you, your T type, and X would be the interpolation factor. Plus copy, which maybe is a detail we don't need to go into, but we do need to be able to copy A in this context. So we have to tell Rust that we need to be able to copy this value. Now, the value type that we're most interested in interpolating in this engine is a stereo frame. And that's because we have left and right channels for our grains. And we're going to perform the same operations on both the left and the right channels all the way through the pipeline. So we read a frame from the audio data in memory. We read a couple of samples out. We interpolate between them to get our interpolated readout. Then we're, well, what are we doing? Oh, we're windowing the data, and we're mixing between two different sounds, and then we're applying panning and gain. And then we're mixing all of these gains together, and all of these operations can happen at the same time on the left and right channels. We don't have to spell out these operations on left and right independently. And we can achieve that by having this stereo frame type, and it's declared as a wrapper for an array of two floats. We don't need to go into the details of the syntax, but it's really we're declaring the stereo frame as a wrapper type or a new type in Rust terms. And here derive the attribute. This is an attribute which tells the compiler to automatically derive implementations of these three traits for the stereo frame type. So we get implementations of clone, copy, and default. And I included default here because it's useful to see that default now is available as a method or a function on stereo frame. So these traits aren't just about arithmetic operations or operators. They're about all kinds of behavior, including functions. If you want to go further with this and implement other traits that maybe can't be derived automatically, then you can implement that trait using this kind of expression where you say implement add for stereo frame, and then you explain to the compiler how to fulfill the interface of that trait. And here we're saying that the output is self, and this is shorthand for the type that you're implementing. So this is stereo frame. And we're implementing a function which is add, and we're going to get self, which is an instance of, well, it's a copy of this value. It's like this pointer in C++. And we receive another instance of stereo frame. And then we're going to add the two inner values together. So 0 here is the inner value, which is the array. And they get added together, and we end up with an added stereo frame. The same applies for subtract and multiply. The really only difference here is the operator that's used. The operator is already available for the array type. And the maybe more interesting case is the scalar multiplication. Here we declare that we're implementing multiply of F32 for stereo frame. And so then here the other type is F32. And in this case, we need to access the two channel elements independently and then multiply those together to produce our inner array. Now that's everything that we need to be able to use lerp with the stereo frame type. We now, well, I've added here an implementation which isn't attached to a trait, but is attached to the type itself. So now I'm adding a new method with function, which is an idiomatic initializer function. For, well, in Rust, you generally implement a new function. And that allows us to show that lerp actually works here. We have 1 and 2 as our A value and 2 and 3 as our B value, and then we interpolate by half, and you'll get values halfway in between for each channel. Now you might be thinking there's a lot of parallel operations happening here on left and right channels. This could be a good opportunity for SIMD optimization, and you're right. And it is maybe useful to talk about SIMD in the context of what's changed since 2018, because in 2018, there were x86 intrinsics got stabilized, and it looked like there was good progress towards stabilizing a high level abstraction over those intrinsics. But that effort stalled. A new effort is happening now to try and get some more SIMD functionality into the standard library, but that's underway, and there's a lot of problems to figure out there, and people are working on it. However, if all you need is simple arithmetic on F32s and you're happy with x86 intrinsics, which I am, then there is a library called Wide, which offers a simple pack of 4 F32s as a SIMD type with implementations of all of the arithmetic traits wrapping the underlying intrinsics. So the plus operation maps to the underlying intrinsic for add for 4 F32s. And then making use of that, instead of our array here that we're wrapping, we're instead wrapping an F32x4. And then in our new initializer, we're putting our left and right channels into the first and second elements, and then we're just zeroing 3 and 4 because we only, in this case, care about 2 channels. Then the implementations of the traits all come for free, except for the scalar multiplication, because the authors of F32x4 didn't add a scalar multiplier. But that's okay. It's easy to implement ourselves just by changing the implementation of the scalar multiplier to take the scalar factor and then construct an F32x4 from it. Then that's everything that we need to have a SIMdified pipeline, because we're using stereo frames all the way through the like the grain processing and then into like the mixing of the grains. We end up with like SIMD pretty much all the way, and then that results in about a 30% speed up, which is nice. And I wanted to highlight this because I think the clean nature of how the traits are designed, and they're very clearly expressed and easy to implement, means that you're encouraged to create these kinds of abstractions. So really, for me, achieving SIMdification of the processing pipeline with a very small number of code changes was like a nice surprise, and that for me really fell out of just the nature of the design of traits. Number 4, now I'm not sure how I'm doing for time, but I'll try and speed up a bit. The ecosystem in Rust is really nice. I think the fact that you have this standardized way of sharing packages means that there is a lot of sharing happening, and there are lots of libraries out there. And what I've seen in the last couple of years is that the quality of these libraries is increasing rapidly, and there are some really amazing projects popping up now. And particularly CPAL for audio had a lot of effort put into it in the last year, and this is a solid like nicely done audio library like RT Audio, Port Audio, and I integrated that into this project really easily. DASP is a nice emerging collection of useful DSP utilities. It's well worth checking out. MIDI-R just worked, a nice cross-platform MIDI library for real-time input, and then WMIDI for like the MIDI types. Crossbeam makes cross-thread communication in Rust really easy. So Crossbeam channel is a subcrate, and I'm using that for MIDI to audio and audio to UI communication, and it just works really well. And Criterion is worth looking at if you're interested in benchmarking. It's a nice statistical benchmarking framework. So the last thing I want to mention about Rust is the feeling that I get with the Rust safety net. And I completely accept that the strictness of the compiler takes a bit of getting used to. It is pretty strict, and especially if you're coming from C or C++, you might find like this feeling of banging your head against the borrow checker. This is something that I felt certainly at the beginning, and often it comes from trying to apply a pattern that you would think works in C++, and maybe it does work, but you aren't able to prove to the compiler that it can work safely. Like maybe it only works by chance, or because you've thought about it carefully, but maybe you've made some mistakes and you don't know, which is where these security bugs come from. And I described the feeling of it as like having a couple of like expert engineers looking over your shoulder as you're coding, and like telling you don't do that. Like you don't want to do that. Oh, have you thought about this? Or like, you know, it's this sense that you've got like experts with best practices pretty well thought through in the compiler. And that might sound daunting at first, or maybe even like oppressive or something. But I think that once you get used to the Rust way of working, and you get used to the tools that are available to you, and you find your feet a bit in the system, in the language, then for me, I found that it's really quite liberating, because once you have like a good sense of how to achieve the high level goals of your project, then you don't have to worry so much about the low level details. The good, well-designed architecture kind of emerges naturally if you follow the path of least resistance. And then when you do need to worry about the low level, like if you're optimizing, or if you're taking care of some very specific functionality, then you can zoom in and then really care about those low level details. But the fact that you're able to shift levels of abstraction, for me, like seems quite natural now that I'm more experienced with Rust. And in the end, I think that this idea that like there's friction to the borrow checker, actually, for me, I find that in the long run, it reduces friction, and that's worth pointing out, I think. So then, in conclusion, what am I saying? I'm saying that I feel different when I use Rust, or I program in Rust, than when I'm programming in C++. And the sense I have is that it's a more pleasant language to work in for me. And that's not going to be true for everybody. And for some people, C++ is a natural language for them. And if you love C++, that's great. And I wouldn't want to change that, and I wouldn't suggest changing it at all. It's fine. And if you're comfortable in that environment, then that's great. But we're at the point now where alternatives are available, and it could be that Rust is the one for you, and it's worth looking into. But yeah, so the theme of the night is alternatives, and they do exist now. So that's all I wanted to say. And if you want to reach out to me at all, then you can find me on Twitter or GitHub. And if you've got any questions about Rust, just hit me up. I'm really happy to answer questions, and anything you want to talk about, just let me know. Okay, so that's it for me.
Thank you very much, Ian.
Yeah, thanks, Ian. Yeah, actually, I have to say, like, specifically one thing that you said, I was, I'm one of those people who are basically naturals in C++, I guess, because that's what I've been doing all my career. But I wish I had experts looking over my shoulder, checking things like dangling references and things like that. So that actually would be great.
Yeah.
I do have one question, actually. So what I hear about Rust from other people, and particularly people who do like DAWs and plugins and these kind of things, is that you mentioned we have quite a few libraries now available in Rust. But what people say they're kind of missing before Rust becomes like a really viable alternative to them is like something like Qt or JUCE, which is like an application framework, which brings all the GUI tools and all the other ancillary tools around it in one package to put together an app. And even more so, if you're doing plugins, you need something like JUCE, which also gives you all the wrappers for, BST and audio unit and AX. And before we did have that, we can't really, in this particular sub-industry, I would say, of the audio industry, we can't really use it like at all. But maybe we're missing something. So what's your opinion on that?
Well, I think you're right that Rust doesn't have yet a large-scale application framework like JUCE or Qt that measures up against those frameworks at all. I mean, they're pretty mature and long-running projects, and Rust doesn't have anything like that. That said, there are projects that are emerging in different domains. So, like game engines are emerging, which are starting to look more and more attractive, and I think it's only a matter of time before the people who get invested in audio and Rust will start to build out the tools that you need to get a full stack of utilities that you need, right? It's only a matter of time, I think. However, something that I showed in the ADC talk was that if you did want to go down the road of having those expert engineers on your shoulder applying best practices to your audio engine for an audio project, you could still use JUCE as your application framework and then hook into Rust via the like C bindings, which is something I showed in the talk. You're able to compile Rust code with a C interface and then make use of that in any other application that would accept C code.
Great. So I have a load of questions here. And if you've answered any of these in here already, please just let me know, because I was just concentrating so much on the questions. So there's a comment from Cass Cassette who says, the pattern matching reminds me of Scala. Do you have any comments on that? Do you know anything about Scala?
Yeah, so the designers of Rust had a lot of functional programming in their background, and I think ML is one that's cited quite regularly, and you'll see similar patterns in lots of functional languages. That's definitely a big influence. I'm not sure if Scala specifically, but those kinds of ideas of how to deal with values, it pops up a lot in different functional languages.
Okay, great. James Bradbury asks, what is the worst part of coding with Rust compared to other languages? I'd be interested in knowing the pain points you have had either in practice or conceptually.
Yeah, I think so. The immaturity of some important libraries has been touched on already. So it would be great if we did have JUCE for Rust. That would be lovely. Mm-hmm. The two main gripes I have at the moment are compile times. And what I'm finding is that actually Rust doesn't compile slowly. It's not a slow language to compile by default. What you get though is that there are important libraries in the ecosystem which use procedural macros, which can then have explosive effects on your compile time. So you'll find that lots of projects take a minute or two to compile, and that's because they're using specific libraries that use specific features. And if you're careful about the way you construct your project, then you don't have to have slow compile times. So my wish for the community over the next few years is that there's a big effort to try and avoid these like really slow features. I mean, it's like in C++ with template metaprogramming, you can get constructions in your code that cause the compiler to lose its mind. And the same kind of thing is happening in Rust, I think.
Okay, great. And I think we've addressed this question a bit, but and there was one that was mentioned in the chat already, but Jose asks if there are any good libraries that you know of to start experimenting with Rust audio applications.
Yeah, I would recommend checking out Nanu, and it's spelled N-A-N-N-O-U. It's a creative coding framework which is similar in nature to Open Frameworks or Cinder. And it's really nicely put together, and lots of great examples to work from. And it has a simple audio abstraction, which is based on top of CPAL. So it's you can hook into an audio callback and get some audio going with a good graphical environment to play around in as well.
Great. And Guilio Moro asks, do traits have to be specified? Can it not infer them from the code?
So it could, but then you would have the same problem that you have in C++ pre-concepts, where you maybe you have a very long function that's generic, and then 50 lines in to the function, there's an operation that needs to be performed with your generic type that then causes a compiler error. And then you end up in a difficult situation where you're trying to figure out what went wrong. And what's much cleaner is that before any attempt is made to compile the function, the contract is checked. If your types match this interface, then the compiler will continue. If not, then you get a really good, clear error message explaining why exactly your function won't compile.
I see. Okay, great. And I think this was more or less the point of your presentation, but let me see if you have any other thoughts. Stesian asks if there was anything that eventually made you decide to go with Rust for full-time development, and what took away some of the final doubts.
So I think a lot of the things that I mentioned really have attracted me to Rust. There's a lot more that I could talk about, but obviously we're short on time.
Okay.
I think if I was I don't know, like if I was working in a different area, like if I didn't have like freedom to choose exactly what I work on, then maybe I would be making more pragmatic choices. Mm-hmm. So if I was starting a plugin company today, maybe it's very likely that I would be using JUCE, and then maybe I would make a choice about whether or not to use Rust for audio or some parts of the stack. But also maybe in the end, we would take a pragmatic choice to stick with C++ there. And that would be sensible and probably wise. But because I'm at a point in my career where I can try out a few different things, it seems to me that Rust has a very strong future ahead of it, and I'm quite happy to be engaging with it for now. Yeah. Great.
Another question from Guilio. What guarantees does Rust make as to memory allocation and in general real-time safety?
Yeah, it doesn't have a garbage collector, which is one of the main things that made it attractive to me in the first place. I for some reason, have a difficulty with languages like D, where the core of the language was designed around having a garbage collector in place. And this might be completely unfair, and I don't know if it's like a valid like concern, but what really like turned the lights on for me with Rust was that this was something that they made a choice on very early on, that they wouldn't have garbage collection. So then the guarantees, I mean, as far as I know, they're essentially the same as in C or C++. You have a, like I think it uses the system allocator by default, and well, I didn't know we had lights in here. That's pretty I've been in the dark the whole time. Yeah, it's basically the same. And then you can override the allocator. So if you want to have a custom specific allocator with specific properties, then you're able to do that if you want.
Great. And I think you might have addressed this a little bit as well in your presentation, but what control do you have on memory copy when passing arguments into a function, i.e. passing by reference or pointer versus passing by value?
Yeah, that's something I didn't touch on, which is that Rust is moved by default. Okay. So when you pass a value in, it is moved. Okay. If you implement copy on that value, then it will make a copy. If that would be a problem, then you pass by reference. And there it's essentially pointer semantics, except for the strictness of the Rust system, where you can only have one mutable reference at a time. You can have as many immutable references as you like. So you can share data around as much as you like in your system, as long as it doesn't change. And if you need to change it, then you have to have the only reference to that data.
Okay. And there's a question from Studio 6+1. With the stringency of Rust, does that mean that Rust no longer requires any sanitizers?
Well, now, I don't know if I would go that far. If you have a safe only project, then maybe that's enough. Mm-hmm. If you're using third-party libraries, maybe those libraries use unsafe internally, and they might claim to have a safe abstraction over the unsafe code, but maybe you're in a position where you don't want to trust them, and then maybe you would want to throw all of your analysis tools at that library as you can. I don't know. I haven't ended up in that situation, but there is an aspect to the unsafe versus safe concept where you have to trust the unsafe code. Mm-hmm. And in the case of like the standard library code, obviously this has been thoroughly vetted and you can trust that it's correctly written. But in the case of third-party dependencies, you have to be cautious.
Great. So Spencer asks, and I think you've covered this, how is Rust ecosystem support for building cross-platform UIs? That's one of the weak points of Rust at the moment. Is that right?
Yeah, there are a few projects that are active that are trying to build a nice UI system for Rust, and there are a few around that are that you could look at. It seems that most projects will end up using GTK or Qt. So there are wrappers for Rust for Qt or for GTK. Mm-hmm. And I think that's what people would normally use. But the way so I haven't thought about this in a while. Before, I was thinking it would maybe make more sense if you have an application framework to instead of trying to fit that application framework into Rust, you would do it the other way around. So you would have a Qt application or a JUCE application, and then you would use Rust as a library that you would pull in. So then you have your full-featured UI framework, but you're using Rust in specific areas where you think it makes sense.
Great. And we have one more question. I think your presentation addressed this pretty well, but any other comments? What do you feel the need is or requirement for an alternate audio programming language? What functionality does C++ lack that other languages offer, such as Rust?
Yeah, the only thing that C++ lacks is the guarantees about memory safety. I mean, otherwise it's like a fully powerful language, right? And within that, you can create all kinds of libraries and frameworks that fit the like the domain that you're working in, and build up something that makes sense for you. So
Great.
I don't think C++ lacks anything other than it's very easy to make mistakes. And if you want to go deep into the language and become an expert in it, then you're going down a path of learning the standard, which will be appropriate for some people, but not appropriate for many others. And then you're working within a subset of the language. And if you're in a good framework, like JUCE is an example, where if you're working within the scope of a particular framework and you kind of play by those rules, then maybe you're going to be fine. And you won't have the kinds of problems that maybe we're talking about.
Okay, great. I guess we'll finish off with one of my questions, actually. In terms of education, because just looking at the syntax of Rust, from my perspective, it looks very tough to me. And I'm just curious from an education standpoint, when you have a team, and this would be a great question that maybe you and Neil would probably be able to address in terms of education for developers and the threshold to get into something like audio development. Let's say in a perfect world where a Rust version of JUCE existed. Do you feel that this brings the threshold for getting into this type of development even higher? Or do you feel that that once we have a working audio framework that's on the same level as JUCE, but a Rust version, that that this will actually make the threshold lower or the same? Do you have any comments on that?
My feeling is that Rust is a more teachable language than C++. I think the concepts in the end are simpler. There might be potentially a lower barrier to entry with C++, but not to writing C++ correctly. Like if you want to write C++ without making mistakes, then I think that's a harder hill to climb. I think if I was starting with a team of developers with no experience in, say, any systems language, then personally I would rather teach them Rust than C++.
Yeah, just to interject, I really agree here. Like on the one hand, why we use C++ is because we have all these libraries and frameworks, but I would also not definitely recommend to start with it. It's just so hard and gets harder as it grows. And I always make this joke that, C++ is growing faster than the rate at which I'm learning it. So I'm actually getting worse at C++ as the time progresses. And I think
that's very frightening to hear you saying that.
And that's something I would say as well, that I think if you're interested in Rust, then you should just take a look. Like it's a good learning exercise. And if you're going to be continuing to work in C++, whatever happens, then fine. You've learned a few things in Rust that will probably make you a better C++ developer.
Great. Okay, I think, we do have one more question from Mark Mossberg. Does Rust have similar binary compatibility issues that C++ does?
Yes, it does. There are discussions you can look at online about whether or not Rust should have a stable API. And it does not at this point. And I mean, I wish it did, but they've decided at this point they're not going to commit to a stable API. So you really need to go down to like C bindings if you want to have like dynamic linked Rust libraries.
Great. Okay, so I just got a message. I just saw a message from Ania that she'll be back in a minute. So while she's on her way back and we're waiting for everybody else to join us for the panel, I just wanted to remind everybody once again that that ADC is happening on the 18th and 19th of November, and that it will be virtual this year. And there is a call for papers. Timur, can you just once again announce where people can submit proposals for talks for ADC.
Yes. So you can submit your talk proposal at submit.audio.dev. And you can do so until the 14th of September, which means you have just about 5 weeks to do so.
Yes, and all talks will be 50 minutes. So keep that in mind when you're submitting for your talk.
Yeah. And the whole procedure about how talks are going to be reviewed is also going to be different this year. So I encourage you to go to to audio.dev, the main website, and just kind of read what it says there, because it might be interesting. Right, so it looks like we're all back. So yeah, let's continue. Actually, now I have to say, I don't know how it is wherever you are, but over here in Greece, it's actually cooled down a bit. So it's approaching 10 p.m. over here. And actually now it's dark and the heat became bearable. Actually, it's quite pleasant right now. And actually the dog that continuously was barking for the first hour of the meetup finally stopped. So that's also good. So things are getting better. I hope it's getting better over where you are as well. So yes, we have one more thing tonight, which is the panel. And since this is a special edition about programming languages used for audio, we're going to be talking about more programming languages. And we had this idea to put together a panel with each panelist representing a different programming language. So we've never done anything like this before. So really curious what's going to happen. So yeah, we have 4 amazing panelists, experts tonight. One of them actually created the language that they're representing. At least one other panelist participates in evolving the language. So we're going to talk about all of that later. But yeah, let me introduce our panelists: Ruth John, Ania Wszeborowska, Neil Burdock, and Jules Storer. So welcome. Thank you so much for being here with us tonight. And yeah, as a first question, I guess, can you just tell us a little bit about yourself, kind of what you do, what language you're representing tonight?
Yeah.
Oh yeah, I guess in real life you would like pass the mic to a person. Yeah. So now we have to. So we can do maybe Ruth, Anna, Neil, and Jules. Maybe does that work?
Hello. Can you hear me okay?
Yep, yes. We can hear you.
Okay, great. Sorry, I had to unmute and unvideo. Who knows what happens when you press buttons on an interface. Hi, I'm Ruth. I'm a self-employed developer, creative developer based in the UK. I'm here representing web audio, which essentially boils down to JavaScript.
And you said you have been doing this for nearly 2 decades now, right?
I know, yeah. I had to apply for a job the other day and it came up. My first initial job was almost 20 years ago, which is, time flies, right?
So yeah, you're truly a veteran in that particular language. So that's, thank you very much for being with us tonight.
Thank you, Tara.
I guess Ania, you're next.
Okay, hi everyone. Greetings from Berlin. It's still hot in here.
Okay.
So I'm representing Python today, which I've been involved with for the last 10 years, let's say, or more. And because I frequently speak at Python conferences and run workshops for underrepresented groups in tech, I got the status of a managing member in Python Software Foundation. Just gives me the rights to vote. Even though I work at Ableton in C++ and C, every day I still use Python. It would be my language of choice for rapid prototyping and for automating whatever I need to automate.
Cool. Yeah, thanks. Neil, are you around?
I'm around. Can you see me?
Hi, yes, we can see you, yes.
How's it going? So as I mentioned before, I'm the VP of Engineering at Lofelt. So Lofelt is a haptics startup in Berlin. So not exactly audio programming, but very similar. Maybe I'll get into it a bit later. My role is more organizational than technical. So I guess my representation of Rust here today is more from the perspective of how has it helped organization in our situation. So like a small team with pretty, I would say, hard real-time cross-platform requirements succeed. I mean, the other benefits that we have are like we're building a greenfield set of haptic design and integration tools. So we don't have any legacy coming along with us. And I think Ian did a great job of explaining sort of the technical details of Rust. And I think my relationship is much more sort of organizational. So don't throw hard questions at me, thanks.
But I think Ian is sitting in the same room, right? So if you have hard
like,
language questions, you can poke him. Yeah.
He's there.
All right. So he's not too far. So
No.
so that's good to know. Yeah, and finally, Jules.
Yeah, okay, me. Well, 20 years. I'm a proper veteran. I've been doing this stuff since the 90s. So I think, yeah, back in the 90s was when I was first doing audio coding. That's when I was kicking off the whole Traction project, the Denterited Door, which is still going. From that came JUCE, which went on to be my next 15 years of career. Until I ended up at Rowley with that. I still am. But Traction is still going, and we're still doing that. So Traction is now like we've now also merged with Prism Sound, so we're doing audio interfaces, door plugins, and then over at Rowley, I've been doing and we make keyboards and controllers and plugins, and so I've covered all the bases here. And so Soul, the thing I'm here representing tonight, which is Soul is my kind of attempt to sum up everything I've seen that I like and don't like over the last 20 years in audio, and try and sort of boil it all down to how I think it should be done. And we've been working on it for about 3 years now, but we're still going strong. And yeah, we'll continue further. That's my main focus.
Right. So, and Soul stands for?
Soul language. That's pretty.
And you did a keynote about that at ADC a couple years ago, and I guess you're going to get more into that later as well, I guess. Cool. Yeah, thank you. That brings me to my next question. Basically, how are you currently using this language? The one you're representing. What are you doing with it, like right now? What are you using it for in your day-to-day job? And I don't know, should we go maybe the other way around? Like, I'm just imagining us sitting on the stage and like passing the mic in one direction, then to the other direction. So I don't know if that's going to work, but.
Name someone. Go for it. So
what?
Just name someone and go for it. We don't have to keep.
Okay, then let's do the same order as before. Yeah, maybe Ruth, Ania, Neil, and Jules.
Okay. This is actually quite a difficult question for me to answer, because the last sort of 6 to 9 months have been not really working on projects for various reasons, which I'm sure all aware of. Previous to that, it was a lot of experience-based work. The web's pretty good. I mean, I'm using JavaScript primarily. I'm working on the web. And this, like classic examples, things like games, WebGL, a lot of sort of online experiences. So a lot of art projects like to work with a browser because it gives accessibility to a lot of people. So some good examples weren't necessarily audio specific, but you integrate audio into those experiences. There's been, like last year, fundamentally a theme was interactive maps. There were games using interactive maps and interactive maps showing experiences that other people were having, and integrating audio like into the whole ecosystem is probably the easiest thing to say that I've personally been doing.
Cool. I guess I'm...
I've frozen the video.
Oh, sorry.
I feel like we've lost Timo. Have we lost Timo? Or
Yeah,
is it
I
just
think
me?
we did.
Right, we're
He's
gonna have
frozen.
to host ourselves, everybody.
I'm gonna step in. Go ahead, Ania.
Yeah. When I'm finished, I'm gonna say I'm passing on. Okay, so as I already mentioned, I use Python whenever I can for private projects, for prototyping things. Like recently I was trying to, I was experimenting with generative audio, and I was trying to get some concepts common use in generating graphic textures, and like adapt this concept to generating audio, for instance. And well, I was trying to do it in C++, but I was just wanted to check if this idea even makes sense, right? So I was thinking, okay, how about I just like quickly hack something together and see if the results are any interesting. So I was thinking, okay, what's the simplest way of coming up with like a simple GUI interface for my algorithm, so that I can turn a knob simply. And like, it took me a day using only like the most lightweight frameworks to just come up with a GUI for something that I didn't even know I wanted to pursue. And I was like, you know what? I'm just gonna like sketch in Python. I used a built-in GUI library and hacked it in 15 minutes. And actually in the end, I decided I was not happy with what I was doing at all and just dropped it. So like, this is why I always like code things in Python first and then see if I actually want to productionize it later. Also, there are like great tools for like plotting curves and doing measurements. So basically I use Python as you would use MATLAB, for instance. So this is for, the audio things. We do use Python and Ableton too, to some extent. Also like Ableton Live is integrated, like communicates with Push and other hardware through Python scripts also. So I do that too at work, or just write my helper scripts too. But also like the reason why I started pursuing audio processing in Python was because people told me that it's not possible, and I guess I just did it and it worked. Like I don't recommend it as like a tool for productionizing your audio projects, but like, it totally works for simple applications in real time also. And also for offline processing, you don't have a problem at all. So yeah, sorry, I've already taken up too much time. I'm gonna pass on to Neil. Was that the right order?
I think it's the right order, and I think we have Timo back.
Yeah, so I actually had a blackout right now. So like everything just bam. But now I'm tethering my phone now, so I should be back, I think. So sorry for that. We had a blackout here in Greece.
Great.
Remote working. What was the question? Okay, so how are we currently using this language? I mean, I guess I need to talk a little bit about what we do. And so why is someone talking about haptics on an audio programming panel? So we provide a haptic design tool and a cross-platform playback engine and plugins to basically try and design and recreate and playback more natural, realistic, richer haptics in sort of games, movies, music than you have traditionally become used to, which are like basically on-off buzzers or rumble in a PlayStation controller. And what's interesting about haptics and audio are they are essentially, so haptics is to touch as audio is to hearing, and they are essentially two sides of the same coin. So we perceive audio as a interpretation of vibrations, and we interpret touch as interpretation of vibrations on the skin. Although on the skin, what we feel are lower frequency vibrations and maybe shorter bandwidth, but essentially it's the same thing. You're talking about waves over time that have a frequency and an amplitude. So a lot of the abstractions or requirements within hardware or software to develop haptic tools are very, very similar to what you would encounter in audio. So things that are similar are like we have real-time requirements, except that we can introduce bigger latency. So our skin is more, let's say, forgiving than the ear if you've got higher latency. Maybe some other differences are you can trick the skin much easier than you can trick the ear. So if you do a mixed modal haptic experience where somebody is looking at something that is telling them what they should feel, they will feel it. Their brain will make up a thing in their brain that tells them this is exactly the feeling of tapping on wood. So we, I guess, have it easier than the audio world. And so what we, well, all the way back to how do we use Rust? So we wanted to build a set of tools that allow us to design and play back haptics. And we were doing it from scratch. And so we decided to start our core implementation of our library. So our data model and our DSP processing in Rust over C++. I mean, these were basically the two options that we had. And so on a daily basis, I don't myself work with Rust. I work with a team who works with Rust every day. And they basically build our data model. They analyze audio with Rust. They analyze audio in real time with Rust. What we don't do are things like build UIs. We don't call native APIs like in iOS. We just throw everything out to the iOS land and call things in Swift and Objective-C. So we have a very small, lightweight core library that runs on multiple platforms that is written in Rust. And I am around that on a daily basis.
All right. Thanks, Neil.
Me. Is this sounding any better, by the way? Apparently my
a lot better, yeah.
Yeah, it was bad because I had an ice pack on my computer to stop it overheating. So I've moved it now and it should be good. Yeah, so what do I use Sol for on the mainly? To be honest, most of the Sol code I run are test suite because I'm working on the compiler. The kind of, I mean, do you want me to do a quick 1 minute summary? I think a lot of people will know about it, but
yeah, if you can do a 1 minute, I think that would be useful. Yeah, 1
minute's tough, but so Sol, yeah, Sol. The idea with Sol is it's a DSL language. I don't know. Actually, it was interesting watching Francesco's talk before. Francesco, you didn't mention Sol, but have you seen it?
Yeah, I did see it.
Because I was sort of looking at your Hello World, and it's like, yeah, that's exactly what we were going for. Like even the order's the same. And Sol is trying to kind of hit several, fix several problems. One of which is the same thing that you, Francesco, were probably thinking, and I was thinking as well. It's like, I want my code to look like that because that's what a DSP block should look like. You declare it's in inputs and outputs. You say what. You initialize it and then you do sample, you loop and you do samples. That's how we should be writing DSP code. And to do that in C++ is awkward because you're threading, etc. So that was one thing I was trying to solve. Another thing we were trying to solve was being able to actually run code securely on different processors. So being able to send it to a DSP or to some other, or to something in a kernel. So being able to write code that is actually trustably secure. And so in a way, trying to hit the same problem that we're trying to address with Rust, whereby someone cannot write some dangerous crashing code in Sol. So trying to create a language where you can't do that, but where it's still fast, which is kind of, I think Sol and Rust are pretty much the only two flexible languages where it can be fast and you can't crash it. For us, the purpose of that was to be able to deploy the code to other non-trusted platforms. And the third thing was to make it easier to write. So again, making it hard to crash helps, but also making it, taking away all of the bad things that we don't want people to do in C++. So having sat and watched countless beginners come to JUCE writing C++ for the first time, they know what they want to do. They want to write some DSP code, and they're just making a complete hash of this C++ because it's such a difficult language, it's such a learning curve. And what they really need to do is go up that curve, learn how to do C++ properly, and then not use all of that stuff because you're not allowed to do all that stuff. You're not allowed to allocate or use threads. And so forget all the things you're not allowed to do and then learn even more about what not to do. we wanted to make a language where you simply you can't do them. They're not there. You can't. This is what you can do. It reads very familiarly to someone who's done any of the familiar languages like JavaScript or C++, and to sort of solve all of those, Soul is kind of our attempt at doing that and making it it's a very commercial project in the sense that it's not an academic project, it's not a toy project. We're trying to pitch something that's practically going to work and is going to solve all the use cases that we see in the industry. What am I doing on it day to day right now? Well, this week I've actually started looking at UI frameworks that we might want to use with it. I think probably what we're going to see happening with it is we'll have people writing their DSP code in Soul, but then using probably a JavaScript GUI around it. We're not going to be we're not going to try and force people into one UI framework or another, but I think React and JavaScript is probably where we're going to want to go. So I've been tinkering with that this week, and also working on our platform layer. So what the protocol is going to look like for controlling a remote Soul device over either across a network or across just from one process to another, or from one chip on a motherboard to another chip, kind of what that protocol looks like. So those are my kind of day-to-day concerns at the moment.
So it sounds like we have some exciting stuff to look forward to, and we're going to get to that
so much
later as well. Yeah. So, but before we get to the kind of exciting stuff, I think I have a more basic question, which I think you, Jules, already kind of answered, because you basically are developing this language and you got into it to solve these problems. But I'm really eager to hear from our other three panelists. Like, how did you get into using the language that we're talking about today? Like, why JavaScript and web audio? Why Rust? Why Python? Like, how did you like get into it? I'm just kind of curious. Like, how did it happen? If you don't mind sharing. Out of all the stuff that is there in tech and in audio,
Are we still going through the same order?
Yeah, I think.
Out. We're just grabbing the mic.
Yeah. Okay, let's do that. And I think, Jules, you kind of already talked about it, so we're gonna skip you this time around. That's okay.
Okay. How did I get into web audio? It's kind of interesting because it wasn't really audio based. Obviously, one of the reasons I use JavaScript is because I know JavaScript. So, oh, hello. Am I still there?
You're breaking up, but we can still hear you.
Yeah, no, my computer's having a freak out now. Timur, it's like, it's here. It's going across Europe.
Okay, maybe if you speaks a bit slowly, then maybe it will happen, because it will be better, because you're breaking up a little bit, but we can still hear you. So
okay, thank you. Yeah, keep telling me if I.
It's fine. It's fine. Yeah, you're good.
It sort of goes back to what Anna was saying about quickly being able to visualize your ideas, which I think, Python's a really good example of this, as is JavaScript, and my flavor was JavaScript, because you can so quickly build something without even really having to worry about build processes or compiling or tools. You have a browser and the code is just there in front of you. So I started playing around with web audio about 10 years ago when it first came out, to analyze frequencies for visuals, because I do a lot of visual art. That's basically where I sit. And it was through that I just became familiar with the API. It's more of a signal processing thing for me. So I may not be creating musical tracks with it, but I sort of fell into it through a visual route rather than a music route. And it's only now that I'm using it am I back into a musical route with it.
That's really interesting. Yeah, thanks for sharing that.
That's okay.
Anna.
Hi. So I think I can only refer to what Ruth has already said. This is like when you feel comfortable in a language, you know it well, and you just want to quickly sketch something. This is probably, what you go for. The other thing, so yeah, so I felt like familiar with Python. I felt pretty quick in it, and that felt like a natural choice. But also, well, before I worked on audio projects, I had different reasons for using it. And then I was actually happy to see how well the Jupyter project progressed, because then it allowed me to also quickly interact with my code and plot things and so on and so on. So like for people who don't know what it is, this is what I mentioned before. You can think of it as like MATLAB-like environment. And Python basically, well, the whole SciPy project supports a lot of, basically has like, maybe I can call them clones of what MATLAB offers also. Has all the libraries for signal processing. So a lot of things are just there, ready to be used. That works well. And the performance of Python is as good as MATLAB's, right? So like my colleagues sometimes use Octave, this open source clone of MATLAB, and this is like twice as slow. We also benchmarked it, whereas Python is only like slightly slower than MATLAB. So for prototyping and measuring things, it was actually quite convenient. But yeah, but pretty much like the reason why I used Python over other dynamically typed languages, or like I could have used JavaScript, but I felt more confident in Python. So. And then there's like a lot of room for optimization when you actually want to do something about your performance issues also. So that's also appealing to me. Yeah.
Oh, because it's like C under the hood somehow, somewhere? Or, yeah.
Yeah, so when you, sometimes when you identify a bottleneck, you can just like rewrite parts of the code into C and write bindings, and that sometimes is sufficient. You maybe don't have to rewrite everything.
Yeah, I guess with JavaScript, you don't really have that, do you?
Yeah, I mean, I can see other benefits of using JavaScript, which is just like basically how easy it is to ship your product and like share it with other people. For instance, this is wonderful, right? So this is great, which also is something that you may do with Jupyter Notebook, right? You share, there's like a built-in, sorry, there's a web client and you can share your projects with people, but like, yeah. So basically there are other scenarios when one technology would be preferred over the other, right?
Yeah, I just want to butt in and say I've been on a very personal journey with performance in JavaScript, and I'm sure Python probably the choice. It's not been fun.
All right. So Neil, I'm really eager to hear, how did you have this idea to start doing stuff with Rust? Like, how do you just, as someone who's, obviously had a, career in this industry for some time before, at a company like Ableton, which as far as I know, does everything in like C and C++, and there's obviously some Python going on there apparently as well. How do you say, okay, now let's build the whole thing in Rust? Like, how do you get into that?
You definitely don't say that, because engineers are like, what the hell are you talking about? Well, I don't know. I guess the question of like, how do you get into using the language? I've only hands-on been using Rust for 18 months or something, but I've been following the language and the progression of the language since before 1.0. I can't think exactly how it appeared on my radar, but I mean, at the time I was working at Ableton, I think I was probably about a year and a half to the job there. And a lot of what I was doing, so I was a development manager for Live, and Live is a really massive and really complex C++ code base. Essentially, I was seeing things that people were having trouble with, and those were all the way from like bugs that are just very hard to diagnose and to fix. And I was working with a hiring team and hiring C++ engineers that have a certain amount of experience and aren't sort of 55-year-old white guys was a big challenge. And C++, it's a beautiful and very powerful and extremely well used language, but it's not very inviting, and it's quite easy if you're a junior to make mistakes with it. And I was seeing this sort of all over the shop, and then Rust sort of raised its head in the world as a potential C++ challenger, which I don't think we've had for quite some time. And I had no ideas or thoughts or plans to try and introduce Rust at a place like Ableton. That doesn't make any sense. I mean, these code bases are mature, and they are hardened, and they are valuable, and they should be treated as such. But it was just something interesting for me to follow. And the more I followed the project, the more impressed I became sort of with its core ideas, with its governance. Actually, its project governance is very interesting. Sort of a more distributed open source model in comparison to the C++ standards committee. Of course, they have different requirements, and so different bureaucracy. And as I followed the project more and more, I became more and more impressed with sort of the people involved in the project, like Aaron Turin, ex-Mozilla, now I think Fastly he just joined. Steve Klebnik, I hope I'm not butchering these people's names, I've only ever seen them on Twitter. Steve Klebnik, Carol Nichols, they're responsible for the documentation culture, a lot of the documentation style, the book, the Rust book. I mean, these were just impressive people. They're, I don't know what you would say, but their care for what they did, I found very, very impressive. And so what started out as maybe this is something that can solve a problem that I see in a particular organization became more of a fascination in terms of like what a technical project could be. I just became quite fascinated with the project. And then when I joined Lofelt, we were coming out of a maybe 12-month R&D mode where we were doing a lot of research and development, doing prototypes into very many different areas it's not worth going into. But we had to then choose a language to write our core model in and our core DSP. And I felt that it just sort of all added up. I was like, this makes sense. We have to evaluate it. And evaluating it was not exactly like there were many languages to choose from with the requirements that we had. It really was narrowed down to C, C++, or Rust. That was it. And we did a fairly significant diligence job on well, we did, the engineers did a fantastic job on making this decision over a significant period of time. And so now I guess I'm more involved or into using the language because I'm around it every day. Whereas before it was just a personal, I don't know, hobby interest on the side for me to follow.
Right. Well, it sounds like it worked out for you quite well then.
I mean, so far, so good. It's not long.
Yeah.
I think we started using it in Feb or something.
Right.
So it has not been long, but so far, so good.
All right, then, yeah, good luck. I hope it works out. So yeah, we have 3 more questions to move through. I'm not sure if you're going to get to all of them, but let's see. So the next question, maybe you can start with Jules this time and kind of wrap around back to the original order. And I would really like to know what excites you the most about basically using the language for audio that you're representing. And are there specifically any recent developments that you would like to tell us about or that you're particularly excited about?
Well, I mean, to be honest, when you're writing your own language, when you type anything at all and it compiles and runs, it feels like a little miracle. When it's like when you're using, I've always had this with any software I write, like you watch your own software running and you're thinking, how is that actually managing to do that without, when you know what's going on in there and how much complexity is inside. But it does feel nice to use. When I actually get to write it, yeah, it's and you can actually express something and it's neat and sits on the page nicely. It's just, I get a buzz out of the aesthetics of code like that. New exciting stuff. We've kind of taken the whole lockdown period as quite a good opportunity to just knuckle down and quietly get on with the back end diligence work. So part of what Sol needs to offer is like a secure layer that means you can run on devices with untrusted code. So we've been doing quite a lot of not front-end language work, but going in the back end and making sure our internal layers are all nice and tight and secure and well tested, and refactoring. I wrote, one of the other funny things about doing something like a compiler is some features which sound very easy are very difficult, and vice versa. So something like adding a little operator would sometimes take us like 2 months and have to rewrite half the code base to do it. But then last week it took me 2 or 3 days to add plugin delay compensation, so it can compensate for an entire graph. And it was like, oh, that just fell out. So nice little things like that.
Because usually that's really hard. And
I mean, that is ridiculously hard. Like,
because I've tried to do this a few times before, and it's really hard.
Bonkers, but that was really easy. Whereas like there are some things like we'll put it the tiniest little addition to the language. Oh God, I have to rewrite the whole type system now because it doesn't handle something, and refactor the whole code. This is one of the nice things that just pops out in the wash. And the thing the sort of visible thing I'm really looking forward to focusing on next will be some GUI options, and actually getting some GUI stuff. I'm going to play around with Nick Thompson's blueprints, is my project for the week, to see how feasible that is. And the other thing is we're going to we're about to kick off a little project to start building lots more DSP building blocks for like our standard library. So really get the basics in there all the time.
Right. So I'm looking forward to actually seeing that in action sometime.
Yeah.
So, cool. I'm just kind of moving on because it's getting later and later. So sorry, I didn't want to like cut you off or anything like that. It's just, Ruth.
What excites me about web audio?
And whether there's any new developments that you are particularly excited about and want to share with us.
I just realized how hard it is to follow rules. It's like, yeah, I'm writing my own language. So I'm like, I didn't write web audio.
But you've been using it for, much longer than, for example, I have even written any code, right? So, so you've been following all that. So it's like it's a different perspective, I guess, but I'm really interested in that perspective.
And it's kind of an interesting API. I think it's good for onboarding, and I sort of covered this. I think it's accessible. I teach on a boot camp here, a web development boot camp. We have adult students, and we actually have quite a lot of musicians come through because they want to learn how to code. And it's really nice to have something like the web audio API, because they have probably experienced some sort of code in some other software that they've used, and they can start to marry the web code that they're learning with their musical knowledge, which they've already accumulated throughout their career. So I really like the web audio for that. It's relatively straight to understand if you have a musical background, and once you've got the coding information on top, it's an easy in, I find. New stuff, we are working, so they have a working group for web audio, and what they do is they manage implementation in browsers, so web clients, as well as any functionality or specifications that need to be written or added. So they're moving through the end of version 1 now and into version 2, and what that means is there's an opportunity to add anything that people found was missing, anything that they want. There's a GitHub repo, it's all open source. I can send you a link after if you want to send it around. Anybody can get involved, and if you're using web audio and there's something that you feel is lacking, or something that you don't like or you want, you can just raise an issue and you can just add it, and it's really cool. Some things that are exciting me about version 2, this is just a couple. There's a huge long list of issues which we're working through. Better buffer management, worklet integration with WebAssembly, which is going to be quite an interesting one. Noise generation, which is simple, but I think it's going to be really effective on the web. We don't really have anything like that in web code at the moment.
That's really cool.
Configuration, yeah, that is quite cool, because I feel like that moves into any kind of generative, any kind of art space, is to have some proper noise in JavaScript, which we don't have. Random numbers, and that's it. And yeah, that is my list. That was my picks from the many issues that I went through earlier. So yeah, it's a really good time. And like I said, I sent. Yeah, well, there's loads more. There's loads more, and I will send a link because there's a community group as well as the official working group, and anybody can just come in and just give their input, really, which is highly valued.
All right.
Thank you, Tim. Just realised it's really dark in here. I'm going to put a light on.
Yeah, I think that would be better, actually. So yeah, Anna, what's going on in the Python world? What are you excited about, and are there any like recent developments that we should all be excited about?
I'd say there's not like awful lot going on in Python regarding supporting audio processing, right? It's true and not true. So let me like elaborate on this. So first of all, I think well, there are like a few projects that offer that like build libraries useful for signal processing that I follow and I'm excited about, and I'm always happy to see progress being done there. They're like the names that come to mind immediately are PyO and Librosa. They're becoming quite comprehensive, so this is nice to follow. I wish there was more happening in the PyPy project, which is like an alternative Python interpreter written in like restricted Python. I like ported PyAudio, which is like a set of Python wrappers on port audio to be able to use it with PyPy some time ago. But like each time I wanted to like benchmark something on this compiler and well interpreter, and I thought it was promising. I just needed to just like add additions on my own, and it would be great. Like if I had infinite time, then probably I would just invest more time into doing that. But there doesn't seem to be like any active workgroups working on it currently. I think the area of computer music that's probably getting closest to the Python world, the Python community, is machine learning, right? And generative audio, because like there are a lot of Python tools that are commonly used in these communities, like, you know, Python wrappers to TensorFlow and so on. And I know that a lot of people use Python for generating musical patterns using machine learning. It's not necessarily my field of research, because like I tend to prefer deterministic algorithm over dealing with heuristics. It's just out of personal preference, but I think this is maybe the field that's emerging at the moment, right? Like Python is gaining popularity in these areas like data science and so on. I was on the programming committee for PyCon US 2 years ago, and pretty much half of the submissions was focused on data science and machine learning, AI in general. So I think this is the most active part in the Python community at the moment.
Right, thanks. So what about the Rust world?
I mean, I don't really know what I would add on top of Ian's talk. I mean, he talked a lot about just the essential benefits of the memory model and the ownership model that allow you to, well, that allow us really to move very quickly and just not experience crashes. One thing about the compiler that I really like about Rust that helps with audio programming or any sort of multi-threaded or real-time system is how amazingly written the errors are. Like, they are just really, really instructive, and they are teaching you all the time about how to program just a little bit better. I mean, they're obviously highly opinionated and they're based on the rules of the language, but they really do help you learn and not make you annoyed. Also, I think Ian mentioned sort of Nano and this and what they're doing in creative coding frameworks. This is a very exciting team. Actually, they're here in Berlin, and they're a part of the Rust Audio working group that I'd encourage anyone to go have a look at what think it's rust.audio. Go have a look at what is going on there. There are a lot of interesting projects coming out. But I think what's exciting to me is more maybe along the lines of what Ruth was talking about. So we're using Rust to, so we compile some of our Rust to WebAssembly, and we run it on a backend server, and we run it in a Node, an Electron application on desktop. And we're doing this for DSP and for a data model. And the, let's say, the compilation story of Rust to WASM is just really quite incredible. And with the sort of the new standard for WASI, so the WebAssembly system interface, I think we have something very exciting in our hands where you can basically have headless WASM running anywhere. And you could write that in Rust, and you could run it in Rust, or you could ship it to a browser or ship it to a WASI container in a network somewhere. This I find super exciting for the possibility of basically distributing audio code. It's very early days, who knows? But I find that the cross-platformness of this solution to be something that's been, I don't know, I think it's burning in the audio industry. So we went from like desktop cross-platform, Mac and Windows, to embedded browsers, back-end systems, our cross-platform or mobile devices. The cross-platform situation is much more complicated now. And seeing a solution that might actually work and is secure coming out of the web world is exciting. And I like that Rust is looking at that as a target, or treating that target as a first-class citizen.
Cool. Well, amazing. Thank you. So I think we don't really have time. We had like 2 more questions that we wanted to ask, but we're kind of running out of time. So I think I'll wrap it up here. I just wanted to say one more thing. It felt to me at the beginning that I should kind of be the devil's advocate on this panel in a way, because I also kind of represent a programming language. Like, if people know like what I do, I'm all about C++. I'm like a voting member of the C++ standard committee. Working on the C++ language is like a significant part of what I do. And, you know, I've done audio plugins for several years, and then, you know, I've been on JUCE team for several years. So it's been all about C++. And a lot of people like do this stuff because it works really well. But right now I feel like this world is almost like, I feel a little bit like a dinosaur, because, you know, I've been listening to you like talking about all these amazing new things that I don't even know, but they all sound like, wow, maybe I should be using this, maybe I should be using that, you know. And it feels like the audio industry is kind of moving on in a way, and I find that really, really interesting. Although there's like, I feel even more that I know just a little bit, and there's like all of this gigantic pool of things that I have no idea about. But yeah, it's just so much exciting stuff out there. So yeah, I'd love to like discuss these like new trends, I guess, more with you, but you don't really have time for that. So because you also wanted to open the floor to some questions from the audience. So I think I'll just wrap it up from me by saying thank you so much for sharing, you know, all your excitement and all these insights. And I definitely learned a lot from all of you today. And I have a long list of things I need to look into now. So thank you very much for that as well. Yeah, so thanks a lot. And I'll let Josh take over and take a few questions from the audience.
Yeah, great. We have a couple questions here. So Scott has a question for Ania. Do you have any recommendations for BST hosting in Python for programmatically calling audio processing plugins from within Python code?
I unfortunately don't. I've wanted to write something like that some time ago. I heard of one project though. And yeah, I've heard only about one. I can try to look it up later, and
yeah,
I'll look up the person who asked, and maybe we can connect. But unfortunately, I don't have any immediate recommendations, which is a bummer.
yeah, I've heard of a couple projects like that as well. And yeah, unfortunately, not really. I think one of the, you can correct me if I'm wrong, Anya, on this, one of the limitations of Python is that there aren't really any good UI libraries for it, or at least I've had trouble finding any good UIs for any sort of controls or anything like that.
there are quite a few projects that you could use. Like I usually end up using the built-in library because I have very limited needs, I'd say, and I think I've also learned my way around it. But you know, you get wrappers for Qt or like more serious, I'd say, GUI libraries. So it is possible to integrate it with a good, fully functional GUI library. I don't think, yeah. Well, but integrating with Qt has its issues. But like, yeah, I think that's not the biggest problem. There are more challenges, I think. Yeah.
Thank you. So there's a question from Peter. I don't know if you can answer this, but are there any plans for embedded Python 3 in Ableton, and is live debugging from attached IntelliJ debugger possible? Not sure if you know that or can answer that if you do know.
Well, regarding any planning at Ableton, we would all have to be under an NDA to talk about this. But like regarding debugging, there is a hacky way to do it, but it's not officially supported, let's say.
Great.
So yeah, like yeah, there is an API, right, that we use to connect with remote scripts with like external hardware, but it's not like officially supported. We don't provide people with tools to develop on top of that.
Okay, great. And there's a question from Spencer for Ruth. How would you compare modern web audio to the way things were done before? Are there any tools or libraries that you use frequently? Oh, I'm sorry, I can't hear you, Ruth. I think your mic might be muted.
I thought it would be clever to mute because I was so hot.
Yeah.
When you say the way things were done before, is that background? Was it background audio tag? Yeah, obviously things have improved a lot since then. Not that there's anything wrong with a bit of background audio when you land on a website. That was a joke. What was the second part of the question? Sorry. Is there any libraries?
Are there any tools or libraries?
There's a ton.
Yeah.
Yeah, because JavaScript is basically libraries if we use it in production, isn't it? Tone.js is obviously one of the most popular. That's incredibly good for any kind of synthesis, any kind of transport timing systems. There's Howler, which is a popular one, which gives you just a layer on top of web audio. One thing about web APIs specifically is they're designed to be built on top of and not necessarily to be used as they come out of the box. So you should build libraries on top of them. So Howler just gives a nice layer on top of web audio just to make some commands easier. Somebody I know sent me one just last week that they had built, which is a good contender by the looks for Howler. And I'm looking at my tabs because I swear I had it open because I can't remember the name. I think it's Sonorous. That is another link that I can provide afterwards. A company based out in New York and Tel Aviv, I believe, they do sort of video editing software in a browser. So they've in their labs department, they've created an audio library, which does look really promising. Like it just makes it easier. Obviously, there's the learning curve to learning any kind of libraries that sit on top of APIs. But yeah, there's a bunch. I can provide links.
Okay, great. Yeah, and what we'll do, if you could send me the links afterwards, and I'll put them in the description below the video afterwards. By the way, this video will be available afterwards for everybody to view, and I'll separate these as well. So there's another question for Ruth from Joshua. Is the web audio API suitable for making progressive web apps that can rival VSTs in functionality? Has there been any movement in terms of cross-browser compatibility for web MIDI?
Yeah, so one of the problems that we have, which I actually do think that, I mean, Neil was talking about it, I think everybody faces it at some point, and that's having something work consistently across the board, regardless of what you're building and for whom. You've either got backward compatibility problems with native, or you have browser inconsistency problems with the web, which is one of the fundamental problems of web development, which everybody faces. progressive web apps are, if people are unaware, it's the idea that you can take your website code and create an installable application on your native device. One of the big trendsetters for this is Google. This works perfectly well on an Android device. One of the blockers that we always face is Apple. I think I heard something recently that Safari as a browser were not looking to implement MIDI, which is, and I just heard that, that's a rumor, and I have nothing that confirms it. And one of the problems that we have with Safari, by and large, is they implemented an old version, well, one of the initial versions of web audio a number of years ago and haven't updated it to fall in line with spec. So there's a ton of stuff which just gets really icky and doesn't really work. And the other issue, of course, is that every single browser you use on an iPhone is Safari. Like Chrome is literally just a wrapper over the top. So under the hood, it's very, very difficult. MIDI is an interesting one. So not only do we have web audio, we have a web MIDI API, which allows you to send and receive MIDI messages. It's one of my favorites. It just hardware enables the browser so easily and so quickly. Works perfectly well in Edge, Chrome, Opera. Firefox are very, very close. They're like, and pray that the recent news isn't going to change that. But if Safari aren't doing it, that's a big blocker. I think the web industry can be quite blinkered to other industries that need things. That's a personal take. Like, I think if they were aware that MIDI would really change the way that we use audio on the web, they'd be more inclined to implement it. But it's still there. It's not going anywhere. You can still use it for Chrome. So, you know, when I'm doing personal projects, I really enjoy it.
Great. Neil, we have a question. Have you ever tried the PS5 DualSense, and where do you think the future of haptics is for game experiences?
So no, I haven't tried the DualSense, and I really do want to try a DualSense. It sounds fantastic. I'm really glad that I don't know, Sony and PlayStation have invested and made a sort of a first-class feature out of haptics. I guess it's good for us. Haven't tried it. Apparently, it's great. Then the question was, where do we think it's going?
Yeah, where do you feel haptics is going for the future of gaming experiences?
I mean, it's obviously the missing piece of the puzzle, right? So graphics development tools and graphics for users have really jumped leaps and bounds every single iteration of consoles, or even now on the web. Same with audio. I mean, if you look at what's in PlayStation 5 with regard to audio, this is pretty incredible stuff. And for touch, this is just the missing piece of the puzzle. And hopefully, with the introduction of something that is more realistic in such a mainstream device like PlayStation, users might start to experience what haptics really can be. I think, unfortunately, we've been sort of dogged by older experiences, lack of design tools, lack of standards. There's a host of problems with why haptics really hasn't developed. One of them being a mainstream delivery system like PlayStation 5. What's missing for PlayStation 5, or maybe will be announced at some point, is a design tool. Like, how do you design haptics? This is a whole new field. How do you design what a footstep in snow feels like? This is not an easy problem, and a whole new, I think, design paradigm needs to emerge there. But hopefully, with a platform that you can actually deliver exceptional experiences on, we will see this move. I mean, one, I think, fantastic example of haptics done extremely well is the iPhone. So the Taptic engine in the iPhone and the invocation of core haptics as an API to get fine-grained control over this exceptional motor means you can do things on millions of devices now that you couldn't do before. And so I guess what's sort of missing is for people to experience them and then for it to become mainstream. My assumption, and of course I'm biased because I work in a haptic startup, is that this will become mainstream and it will become something that people come to expect and people learn to do well. I suspect there will be poor implementations, a lot of them to begin with, but hopefully that best practices emerge, thought leadership helps people do the right thing, less is more, all of that. So I am very optimistic, but I am also very biased.
Great. And we have a question for Jules. Controversial question: is Soul being developed to possibly be an eventual replacement for JUCE? Will JUCE ever be replaced?
I'll never get rid of JUCE. That wasn't the idea with it. I think as long as people are writing audio code in C++, then JUCE is going to be around for that. I think ultimately, I mean, my kind of prediction for the world will be that as OS is getting more and more security conscious, and as processing becomes more heterogeneous and moves on to different chips and gets more distributed, it's just going to be impossible to run your C++ code where you want to. In the same way, like, 10 years ago, browsers used to let you embed some C++ code in an ActiveX control or something, and gradually it just became JavaScript, and you could do everything in JavaScript, so that's fine. And I think in 10 years we're going to look back on plugins that were written in, and the idea of like having a door that loads other people's C++ code into the same names, into the same address space, and lets it just do whatever it wants. And the idea that OS would let that happen on its audio, if it has an audio chip over there, whether it's a DSP or a little CPU, I just don't think that entropy is pushing us away from that. I don't think that we're going to have native languages on these actually doing this job in the far future. In the near future, definitely there are JUCE isn't going anywhere in the foreseeable future, because there's just so much code out there using it. There's so much C++ code. There's so much so many companies with million-line code bases based on JUCE. So definitely not trying to replace it, but it felt to me like something would eventually replace it, and I didn't want someone else to make that thing. I thought, well, if something's going to displace this way of doing code in the future, and I think it will at some point, whether it's near or far, I at least wanted to have a hand in designing what that thing could possibly be, and having my go at it. But it's not. It's not a replacement. It's a parallel thing for the foreseeable future.
Okay, great. And my dog Toast has decided to join us for this live stream. She's learning the code. So another question for Ania. Do you use C, Python, or PyPy?
Yeah, so I mentioned briefly that I tried using PyPy. I use CPython mostly. I used PyPy for those who have never heard of it. CPython is the default Python interpreter written in C, whereas PyPy is a Python implementation written in restricted Python. It's supposed to be faster, and it is for many use cases, but not all of them. And I wrote like a silly, simple sampler and benchmarked it on different Python implementations. And PyPy was slower, actually. That was very disappointing, and I've been meaning to find out details why. I think maybe the PyPy implementation of NumPy, which like NumPy is a library offering a lot of vectorized data types. Maybe this is a problem. I've been meaning to look into it, but like the fastest was so far was the Python 2.7 implementation of CPython with all the computer processors switched off by one, right? So like Python can't run like on different processors. So it's basically gonna be like switching and locking, process. So basically when you disable all the cores but one, your Python code executes faster. So yeah, long story short, I've tried using PyPy and it didn't yield promising results. it would be nice to understand why and maybe help advance the project to improve this, but it's not the case yet.
Fantastic.
I think we need to wrap up soon, but actually I just saw on the Zoom chat that Ania, you have a question for Jules.
Yes. So I have a question about Sol. Since you mentioned that it's domain language, right? Like it's has the simplified syntax, and I wonder what it's like to debug in it. What it's like when everything works. I assume like it's great. It works out of the box most of the time, which is great. But what happens in the situation when actually something doesn't work? I don't know what the licensing plan for Sol is either. So is it possible to see the the underlying code and be able to figure out what's going on, debug it? So I've just been wondering about.
So you're talking about debugging Sol itself and not a Sol program?
A Sol program,
yeah,
or maybe Sol itself. Yeah, it depends what.
There's all different layers of debugging here. We haven't written the Sol debugger yet. It's on the to-do list. That's a tough one. It'll probably end up being an interpreter, so you can step through, and we'll have a tool that can like interpret the code, so you can inspect things. One of the nice things about the language as well is that because the whole thing is completely state-based, like the state of a Sol program is one chunk of memory, literally with one chunk of memory, everything stays in one place. You could actually have a debugger where you can scroll backwards and forwards in time. You could actually record the entire history of the state or take snapshots of the state. So you can actually rewind to any sample that's been played at any point in the program and actually then inspect every variable, which I think is kind of the ultimate, audio coder's debugging dream. Is like, oh, what was that click? Roll back a few seconds. Oh, it hit, and then look at the actual thing that happened. And then if you end up actually having a problem with the Sol compiler, JIT engine, generators themselves, yeah, we do ultimately want to make everything open source. That is definitely where we want to go. Right now, we've released most of it as open source, all the front end stuff. We're keeping back some JIT engine code just because we kind of have some discussions going on, legal stuff and business stuff behind the scenes, so we're kind of holding some back, but ultimately I want to see everything out there and make it all completely debuggable down to the lowest level. That's the plan. Great.
So we have time for one more question, and that is for Ruth. What was the name of the boot camp that you had mentioned? And before I forget, afterwards, can you send me a link to all this stuff so I can put it in the video description?
Yeah, I've got all the links. Do you want me just to drop them into the Zoom chat now?
Yeah, that sounds great.
Okay, I'm going to do that. So the bootcamp is actually a local one. I live near Bristol in the UK, and about 5 years ago, when I left, I had a research and development job at a big telecommunications company here, and I left that, and I was immediately approached by the founders who were doing a localized course. It's a 3-month course to teach people how to code, because there was such a lack of resource within Bristol. Like, there was plenty of jobs and the skill wasn't there, so they approached me to start teaching, which I've been doing ever since. It's been an incredible experience. Definitely one of the most fulfilling things I've ever done. I really love teaching. The name of the company is Develop Me Training. You can just Google that, but they are Bristol based. So
okay, yeah. Develop Me Training.
Yeah, I could probably give you a link for that as well.
Great. Okay, so we need to wrap up now. And that's everything. Oh, I hear some weird talking in the background. Thank you very much to all of you for joining us and for your contribution, and absolutely amazing meetup. Thank you very much. And also thank you to the sponsors, JUCE, Sonux, and Focusrite, for supporting the meetup. And does anybody else have any more comments before we sign off? Thank you very much.
Just want to also say thank you very much to all the speakers and the panelists. I learned so much from you tonight. Thank you very much.
Yes.
Really
Thanks
enjoyed
for
that.
having me. I'm sorry that I was melting all the way through. Right, I found a solution.
We
My
all
ice
were.
pack's finally given up, so it's a good job we're finishing.
Yeah, and I'm not sure how much my UK phone tethering data is going to last in Greece either. So,
And as I said before, these videos will be available afterwards. Also, if you have any other questions, feel free to join our community. It's on theaudioprogrammer.com/community. And there is actually one other announcement. We will be having our next meetup on the 8th of September, so every second Tuesday of the month. And we have some awesome guests that are going to be joining us for the next meetup, and we will announce them soon. So thank you for everybody that joined. At our peak, we had well over 200 people that were tuning in at once, which I find is amazing for such a niche branch of development, and it's all because of you. So thank you very much for joining us today.
thank you and good night.
Have a good night.
Thanks.
Thanks.
Bye.
We're not signed off just yet. 1 second. And we're off. Thank you very much.